everybody. This is the 33rd video of the ongoing C++ series, and this has been a wonderful journey so far. So today's video, I want to discuss about function overloading and function overriding. So function overloading basically is the beginning building block. So it doesn't cover that much of OOP, and it's not based on OOP, function overloading, but function overriding is based on it. So when we come on function overloading, it's basically some kind of feature that or method overloading is the ability to create multiple functions of the same name with different implementations. And the meaning of implementation means different types of parameters or different types of return types. So the name, the identifier of the function will be same. Suppose we have a function, let's say add, and it has a return type of int, and it has two input parameters, two arguments. But now you want to create another function with the same name, but suppose the user wants to, instead of adding two numbers, wants to add four numbers. We're not going to create a different function and a different name and everything. That's just so confusing. We want the ability to have an additional feature for that same function just to cover a different manipulation. So for that, we use function overloading. So we include four arguments instead of two. And we just name this name of the function the same as it is. So now we're going to cover up it in our IDE. So I'm going to open up my IDE. I'm going to include my necessary header files. So namespace standard. Then we have integer main. And we also have the return 0 semicolon. Okay, so what we're going to do here is we're going to create functions. So first function over here is, first let me save this code. So I'm going to name this as code 10. And I'm going to name my first function with a return type of int, and it will have two multiplications. So we're going to say mult, and it will have an integer a, and it will have an integer, b. So what I would do is going to return the result. It would return a asterisk b. So this is my basic function. It's called the mult function. Now I want another function. So I say, for instance, if I have two double types. So if I say mult, I create the same name. So it would be double a, and it will have double b. Now you know that the name is same, but the arguments are different types, and this could work. So this is the example of function overloading. It's an example of polymorphism, and polymorphism is basically a feature in the C++, and we're going to get into more detail in the upcoming videos. So what overloading function must have is like different types of parameters. So for instance, I have two functions over here. One is mult with an input parameter of two ints. One is mult with two input parameters of the double. Now this is overloaded, so means these two functions can be overloaded. Now different number of parameters as well. So for instance, if I have the same kind of function, let's get this one. So I copy this one and I paste it right here. And instead of having two, I'll get another, and then I'll put C over here. So what's going to happen is it's multiply all three of these integers. Now it has the number of parameters also matters. So this is also overloaded. Now these three are overloaded. Also the number of the different sequence of parameters also could cause, meaning if you have something like, I could change up the sequence over here. For instance, if I have a return type of double and I have mult, I could have double a, and then I could have int b, and I could have int c. This could also work, and this is also overloaded. So we could have a asterisk b asterisk c, and this is also going to work. So now this is my overloaded function, and I also create one more just for example purposes. So I would just copy this, and I would paste it right here. But in this case, what I'm going to do is I'm going to, instead of having double over here, I'm going to have an int over here. And I'm going to have a double here, so a double here, and then a double here. So I'm just showing you that the sequence also could be changed. Now what we want here is we want to show, also want to prompt that which function has been called. We could call this as function 1, and I'll just copy this snippet, and I would paste it right here, and I would paste it as function 2 called. And over here we'll say as function 3 called, and over here I would paste it as function 4 called, and over here I would call it as function 5 called. So now I created 5 functions with the same name and different return types and different input arguments or parameters, whatever you like to call it. Now, this is where the fun comes in, where you just have to call the function. So I'm just gonna invoke the function. I would say invoking. So I'm invoking the function TION. I'm invoking a function. I'm going to put input parameters. So for instance, I want to call the first function. And I know in the first function, it had 2 input arguments. It had int A and int B. So I put 2 inputs and 2 integers. So I say 3 and 7. Now, my answer is supposed to be 21. Let's see if I get 21 over here. So I save the code. I execute and compile and run this. Now you can see over here, function 1 is called and the answer is 21. Okay, so that's nice. How about wanting to have more than 2 input parameters? So what I do is just, what I want to do here is, for clarity purposes, I want to structure the code so that it looks neat and tidy on the output screen. I would give an end line over here, and I would just copy this code and I would paste it here. And instead of having 2 inputs integers, I would have 3 integers. So I would put that one more over here, which is that. Now, instead of having 21, I would have 42 because it's multiplying by 2. So let's see if this is the case over here. So execute, compile, rebuild all. So the funny thing is, when I was executing and seeing my result, what I expected was 42. But the thing is, function 3 did call, and I wanted to call the function 3. We had 3 input parameters of ints, but the answer was 147 unexpectedly. What I did was I check over here and I said on function 3 I'm multiplying b 2 times. So that's the typo, whatever logical error I made. Now I'm going to fix this and hopefully 42 will be in the output. So you can see over here 42 is in the output. Now we could have more than that. We could call the ones with the doubles. So I'm just going to copy this. I'm going to paste it over here. And instead of writing something like that, I would say, let's see, we'll say 2.5 and we'll have 7.5. Now let's see if this is an answer and which function is it. I'm going to be calling, let's see which function is the 2 doubles. So this is the function 2. It's going to be calling that. So I'm going to see function 2 calling and it would give me a result. And it would give me a result of 18.75. Let's see. So I save the code, I execute, compile and run this. And you can see function 2 is called and 18.75 is the answer. So far, so good. And we could do this as similar to all of our REST functions. So this is the beauty of function overloading. Again, I would like to say that this is totally independent of OOP. And I haven't highlighted any object-oriented programming concept in this. So the next, which is function overriding, will be based on OOP. So function overloading, which is very convenient, and why it is used. The important thing is that when it comes to having professional code and you're working in a company where there's so lengthy code, where there's so lengthy functions with so many lines, and what you want to do is you want to create another feature where the user has to input nothing, like it doesn't need to input anything, and you want to show some kind of result to that. For instance, if your user is inputting 2 numbers, one user doesn't want to input any number. So how are you you're not gonna create another function. You're gonna do the same function, but you're gonna overload it using the same name and just adding a feature to it. So that's the beauty and the benefit of function overloading.